Hello, ladies and gentlemen. Today we're going to talk about what sides make a triangle, and we're also going to talk about the angle relationships. So you are going to want your notes. Hopefully they're already glued into your notebook. Maybe a calculator, and then definitely something to write with. So what are some things we already know about triangles? Hopefully, if you just sat down and thought about it, you would know that triangles have three sides. And if they have three sides, then they have three angles. Definitely something that we probably already knew subconsciously. We also know that the angles inside of a triangle are going to add up to equal 180 degrees. We know that equilateral triangles are going to have equal sides and they're going to have equal angles. And we know that isosceles triangles have two equal sides and two equal angles. So again, these are already things that we already know. So how is this maybe going to help us in today's lesson? Again, the key question is, do any three sides make a triangle? So that's what we're going to try and figure out today. Any three given sides, are they going to form a triangle for us? So imagine with your partner, if you had a partner, you have the following tools: 3 paper clips, 3 pencils, and 3 rulers. Now, if you have those tools at home with you, you can sure go ahead and grab them out. But we're going to use our imagination here. So imagine you have those 9 things. All right, with those 9 things, we're going to determine if the following can make a triangle. And remember, triangles do not have tails, so we're going to want to make sure that we butt up all the ends together. And again, if you have these materials at home, you can do this with me. If not, let's just use our imagination. So we're going to write yes or no as we go. So the first one, we have 2 pencils and a ruler. Now, if you think of that, that means 2 pencils go on the end of my ruler, and would they be able to touch? I believe that they would. Okay, so I'm going to put a yes. This would be that isosceles triangle that we would talk about, where 2 of the sides are exactly the same. So that one's going to be a yes. Next thing we have is 3 rulers, and if I put 3 rulers all butting up their ends together, again, this is that equilateral, so I would assume that those are going to be a yes. And again, if you have the materials, you can do that, but if you use your imagination, hopefully you're thinking it through. Next, we have 3 paper clips. Again, since they're all the same size and we bud them up against each other, as you kind of envision that, that would be that equilateral triangle again, so that's a yes. So then let's think about 2 paper clips and a ruler. So again, a ruler is that 12 inches and a paper clip is about an inch. So if we put the paper clips on the end of that ruler, hopefully when you envision that, you're kind of thinking, well, that doesn't make sense because those paper clips definitely wouldn't reach each other. So this one's going to be a no. 1 ruler, 1 paper clip, and a pencil. Okay, that 1 ruler, again, 12 inches. Paper clip would be about 1, and a pencil would be about 6. So if you think about that, I don't quite think the pencil and the paper clip would work to reach each other. So again, I'm going to have a no there. 2 rulers and 1 paper clip. So the paper clip could be like the bottom of that triangle, and the rulers could butt up on the end of the paper clip, and they would definitely touch. So that one would give me a yes. And then we have 1 pencil and 2 paper clips. So 1 pencil and 2 paper clips. This one, again, I don't think those paper clips are long enough to reach, even if I do put them on the end of those pencils. So this one I would say is a no. And now, what if I had 2 pencils and a yardstick? So a yardstick is about 3 feet. So if I put 2 pencils on the end of a yardstick, would that make a triangle? I don't think it would. I really don't. So I'm going to have to say no. So you're probably wondering, what in the world are we even talking about all of this for? What does this mean? So again, our key question is, any 3 lengths make a triangle? So again, can I make a triangle with any 3 sides I want? So obviously we found that they can't be any size I want. So what's the definition? In order for 3 sides to make a triangle, the 2 smaller sides must add to be bigger than the third. So again, get this definition written down and pause it if you need to. But 3 sides in a triangle cannot make any 3 sides can't make a triangle. In order for them to make a triangle, the 2 smaller sides must add to be bigger than the third. So again, that's important. Jot that down. Pause it if I'm going too fast, but make sure you get that written in your notes. The 2 smaller sides must add to be bigger than the third. So, in our other notes then, determine if the following side lengths could form a triangle. So again, the 2 smaller sides, the 2 smallest sides have to add to be bigger than the third. So the 2 smallest sides here, I have 8, 17, and 24. So the 2 smallest would be 8 and 17. So what the definition told me is if I add 8 and 17, these two added together have to be bigger or greater than the third side. So 8 plus 17 has to be greater than 24. 8 and 17 makes 25. Now, is 25 greater than 24? It is, so then I would write, yes, these three lengths can make a triangle. Next example, then we have 3, 3, and 7. So the two smallest would be 3 and 3. So 3 plus 3 has to be greater than 7. 3 plus 3 is 6. Is 6 greater than 7? It is not, so these three side lengths would not make a triangle, or no, they would not. Last I have 41 inches, 7 inches, and 35 inches. So again, my two smallest would be the 7 and the 35, and that has to be bigger than the 41. So even though they're not written in order, we got to make sure we know that 7 and 35 are my two smaller sides. So 7 plus 35 would make 42. Is 42 bigger than 41? It is, so these three side lengths would then indeed make a triangle. Now we have a bunch of different questions here, but let's just focus on a couple. Let's focus on C. We will do C, we will do D, and we'll do E and H. So these are the ones we'll do today, okay? So 15, 5, and 6, again, making sure that the two smaller sides, so 5 plus 6, have to be greater than 15. 5 plus 6 is 11. Is 11 greater than 15? Hopefully you're thinking, no, it's not, so we would write no. Next we have 20, 20.5, and 20. So the two smallest would be 20 plus 20, have to be greater than a 20.5. So is 40 greater than 20.5? Yes, it is. So those would then make a triangle. Last we have 1, 2, and 3. 1 plus 2 has to be greater than 3. Is 3 greater than 3? Now this is a trick question, I think. Is 3 bigger than 3? It's not. So this one, even though it equals 3, would not form a triangle for me because it has to be bigger than that third side. Next we have 4. 3 square roots of 2 and 8, but I don't even know what 2 are my smaller sides. So what I would have to do is I would have to grab my handy dandy calculator and I would have to type in 3 square roots of 2 into my calculator to know what that even is as a decimal. So that is going to be about 4.2. 4.2 is about what that equals. So then I know that these two smaller sides, 4 plus 4.2, would have to be greater than 8. So is 8.2 greater than 8? It is. So then again, we would have a good triangle. And again, if you don't know whatever number it stands for, just type it in your calculator, get a rough approximation, and then add from there. Because again, as long as it's bigger, we're good. If it would be smaller, we're not good. So, given two sides of a triangle, we need to set up an inequality to show the range of possible lengths for the third side. So, if I were to take 3 and 11, what are the possible lengths that I could have for the third side? So again, remember, in order to make a triangle, the two smaller sides would have to be bigger than the third. So if these are my two smallest, I could add 3 plus 11, and that would have to be greater than this unknown in the middle, right? So 3 plus 11 is 14. It has to be greater than that unknown x. So if I were to switch this around, x has to be less than 14, okay? Because in order to make this a true inequality, 3 plus 11, again, if those are my two smaller sides, those would have to be bigger than that third side. So the third side would then have to be less than 14. On the other hand, what if these are my two biggest sides? Okay, what if it's something less than 3? Then to get that other length, we would have to subtract. So I would take 11 minus 3, and x would have to be greater than that. So 8 would have to be less than x. So x would have to be greater than 8. So when I look at this and I make up this equation, the range of possible values would have to be between the numbers 8 and 14. So again, making sure that we really understand what's happening here. If I used 8 here, my two smallest would be 3 and 8. So 3 plus 8, is that bigger than 11? It's not. So I would have to use a number bigger than 8, which would be 9. So is 3 plus 9 bigger than 11? It is. So again, if I used 14 then as my third, the two smaller would be 3 and 11. Is 3 plus 11 greater than 14? It's not. But what about 13? Is 3 plus 13 greater than 14? It is. So then the good range of numbers would have to be between those two, between the low and between the high. So again, when you're trying to figure out the range, you're going to add them together to figure out that high range, and you're going to subtract to figure out the low. So if I add 28 and 31, add 28 and 31. 28 plus 31 would be 59, so it looks like my high range is going to be 59. So x is going to have to be less than that. And if I subtract them, my low range, my x is going to have to be greater than 3. And again, if I added these in, if I added 3 or I added 59, when you add them, again, that's how you figure out whether they work or not. So if this doesn't make sense, make sure you're jotting down those questions so we can visit that in class. But again, in order to figure out your range, you add them to get the high value and you subtract them to get that low value. So same thing here, I'm going to add 24 and 7 to get my high. So the high is going to be a 31. So x has to be less than 31. And the low is when I subtract them. So when I subtract 24 and 17, I get, or 7, I would get 17. So the range for this bottom one would be anywhere between 17 and 31 would give me a possible length for my third side of my triangle. So again, that might be a little bit confusing. Making sure you jot down whatever questions you might have so we can address those in class. All right, so the next thing we're going to talk about today is angles and side relationships. So how my angles maybe relate to my sides. So again, you're still working in those same two foldables, still having something to write with, and you might need a calculator. You probably won't need a calculator for this part of it though. So how are angles and sides related? We really need to figure this out. If we were in class, I'd tell you to watch me and I'd hold my arms up and I'd look all crazy. But now if I'm making a small angle, okay, let's say I make a really small angle here. Okay, so this is the angle I'm talking about. I want to figure out how this angle here relates to the third side of my triangle that I don't have drawn in. So I'm going to make these in different colors actually. So I'm looking at this angle and this side length here. So I have a small angle and you can see that this side length here is maybe a little bit smaller. So now what I'm wondering, okay, what if I changed that? What if I made that a bigger angle? So I'm now looking at this angle and how that relates to maybe that third side there. So big angle, third side. Okay, let's make one more maybe in the middle. So if I have just a middle angle here. So again, how that third side relates to this angle here. Okay, so again, how does this side relate to the angle that I had drawn in? When the angle was really little, the side itself was really little. When the angle was bigger, and even if I make even a bigger angle, let's make a bigger angle like this. So when that angle is even bigger here, how did that relate to that third side? Made a bigger side, right? So when my angle is bigger, the side across from it is bigger. When my angle is smaller, the side across from it is smaller. So how does that maybe roll over into when we're talking about how those angles are going to relate to the sides? So notice again, this big angle, the other two angles in here, if I put those in purple, are really small, right? When I had a small angle, the other angles are bigger angles. Same thing, bigger angles, small, smaller angles, maybe bigger here. So again, how is that going to relate? Hopefully you're thinking that the small angle, so here's my small angle, is across from my small side. Same thing, my big angle is across from my big side. Okay, so remember that as we kind of jump forward and jot that down here. So let's look in here then how these are going to relate. So if I look at x, so if I'm talking about the angle x, the side that x kind of has an effect on would be the side y, z. Okay, if I look at y, the angle y is going to have an effect on the side xz. And if I look at angle z is going to have an effect on the side xy. So again, knowing that as we adjust those angles there, the sides that they affect are directly across from them. Okay, so keep that in mind as we kind of discuss like what's happening. As we go to fill in these notes then, the smallest angle is always going to be opposite the blank. Hopefully from that first kind of demonstration when I had the smaller angle, again, we realized that it was across from the smaller side. So the smallest angle is always opposite the shortest side. So then vice versa, the largest angle is always going to be opposite the longest side. So now this is how you might kind of see some questions. Order the angles from least to greatest. Based on this triangle, we want to order them from least to greatest. So if I'm trying to find the smallest angle, we know that the smallest angle is opposite the shortest side. So what side is the shortest? Hopefully you're thinking AB is my shortest side. So the smallest angle better be angle C. Okay, now the next smallest angle would be the next shortest side. So the next shortest side would be B to C because 17 would be then my next biggest number, my next number in line. So across from B to C would be the angle A. Lastly, then my greatest angle would be across from my largest side, and the largest side is 24, so that's AC. So the largest angle in this triangle would be angle B. So again, they wanted least to greatest, so we found the smallest side, the next biggest side, and then the biggest side. If you want to do the smallest and the biggest, and then just put whatever's left in the middle, you could do that as well. So if we kind of flip that thought process around, and we talk about shortest side, then the shortest side is always going to be opposite the, hopefully you're thinking, smallest angle. Likewise then, the longest side is always going to be opposite the largest angle. So again, right now I only know 2 angles in here, so I don't even know what that third angle is. How could I maybe figure that out? Hopefully you're thinking, well, every triangle has 180 degrees. So if I can add the 2, so the 59 and the 53, add those together, that leaves me with 112. So I've already used 112 degrees. Well, what's missing? I could take 180 and subtract 112 to give me a value of 68 degrees. And I need to know that before I can figure out the smallest and largest sides, because I need to know which angle is the biggest. So with that being said, we want to label the sides from greatest to least. So we got to find my biggest angle in my triangle. So the biggest angle is angle D. The side across from angle D would be the side EF. So that would have to be my longest side because it's across from my longest or my largest angle. Okay. Then if we wanted to find the smallest, so the smallest angle would be this angle of 53, which is F. So the smallest side would have to be the side ED. So that would have to be the smallest side. And again, if I do the largest and the smallest, that leaves me with only one side remaining, which is the side DF. That would have to be in the middle, across from my middle angle, or the angle that is not the smallest, but not the biggest. It's right in the middle. Okay, so again, 3 sides ordered in greatest to least. So if you have questions as you're writing these down, make sure you jot them down so we can address them in class. I know I kind of talked a little fast in this video. Got to be one of the longer videos, but pause it, make sure you get everything written down, and take good notes because we'll work on this next time I see you. So I want to thank you for taking good notes, and I'll see you when I see you.